Hello. If all works well, we are now live and you guys should see me. I cannot see you. That's fine. Welcome to this first webinar by Advantis Academy. Thank you all out there in the world for joining this first session. Very excited. We have a good participation. We have, I see a lot of folks that well know me and I know them have registered. Thank you for that. And we have some new faces. That's great. So with that, let me get my presentation started. Here we go. Okay, so thank you, Razi, for the confirmation and Mudir. So I hope you guys can now see the presentation and myself. So a little housekeeping things for this tool, which we are using for the first time. So bear with us. I hope it works the way we want it. As far as the content, the size, you have on the upper right corner, you have that little minus symbol there. That's where you can make me smaller and the presentation bigger in case you have a hard time seeing certain graphics or fonts. And then you can make me bigger the other way around if you think anyway. So that's that. You can also go full screen on the tool up there with the two arrows. You can, with the arrow pointing to the right, you can turn the chat off. So that gives you even a bigger screen. Okay, that so far for the tool. When you first enter, you're all muted and without video, which I then have to enable, which is my full intention at some point, but not now. So let's get started. Got way too many screens here. Okay, before we get started, one important fact. You are being recorded. We will record this session, so please be aware when you do join by camera, if you want to turn the camera off, if you don't want to be on camera, we just wanted you to be aware. We have not decided if we're only going to show this content to the members inside the restricted area with Advantis, or if we're going to make it public on our new created YouTube channel. As most of you have heard, we have now launched through Advantis Academy. This is our knowledge channel where we channel everything through. So and the YouTube videos are part of this new communication channel. So with that said, let's look at the agenda. What we have planned for today. First, brief introduction for the ones that do not know me nor Advantis, just briefly, out of respect, not too long. Then we're going to talk about the amusement standards, give you kind of the big picture of our industry, why things are the way they are, why we do things, what we're doing. And then also what the current situation is on the EN, ISO, and Astm side. Those are our three standardization bodies that we have standards in our industry. And then also how the connection works to other, the ISO standard and the ANSI standard, because that has some relevance. That's on the standard side, and then we do a Q&A session here. So again, latest by then, you should have your hair combed, all your shirts buttoned up, because at that point you might be on camera, just so you know. So you got some time, get ready. Then we're going to look at those 5 key elements that I've put together what makes a good risk assessment. Basically, these are things that I came across in my work so far on risk assessment that I either thought about my own risk assessment that were not ideal, or that I've seen from others that I thought this is not ideal. I mean, to a certain extent, it's not in accordance with the standards. It's so not ideal. So I will point this out. I'll point out what the things are that are simply against the standard that you can't do, or it's not a risk assessment. And then there's other things that is more like my experience, my flavor, what works well. So these are kind of the Phil Gehring features that you can consider, but you don't have to. And with those 5 elements, we, again, would like to have some exchange. So if you have an immediate question on one topic, let's just clarify that right there. So the session is set up for 90 minutes. I hope we're going to make it through in time, but the session can last up to 3 hours. Not that I intend to do that, but just so we know it. The tool allows for 3 hours. Okay, so let's jump into this. About myself, just real quick, my background is electrical engineering. So control system design have I been doing for the last 25 years. Started in the industry with the ride manufacturer here in Switzerland, doing hardware design, software, PLC software coding, and commissioning. More and more, the risk assessment topic came up, also in particular around functional safety. When you talk people moving systems, control system, functional safety is something that started early in the early 2000s as a new term, and I was intrigued by it and jumped on this first certification program, the CFSE. This is Certified Functional Safety Expert program, and I got my certification back in 2001 on that one. A bit later in my career, I worked for a good amount of time as an accredited ride inspector. The reason for bringing this up is, as a ride inspector, if you do design reviews, you see many risk assessments from others. So that's where you see a lot of what can work and what cannot work so well. As far as the standardization, we'll talk about standards a bit more, but those are the CEN TC and the ISO TC. Those are technical committees. Those are the committees that create the language in the standard. And there's these 2 committees, 152 and 254. And I'm a member of both of them, responsible for electrical equipment. So that's all the ride cable size, basically all around electrocution, fire, that kind of stuff, and then control system, which is then more functional safety topics. At Astm F24, I'm an executive member and a co-chair, one of the 2 co-chairs for the new standard that's being developed right now on risk assessment. And I'm happy to know that at least he registered. My other co-chair is Kevin Russell, and I saw him on the registration list. I hope he was able to make it. So between him and I, we hopefully be able to answer all your questions on that end. And last but not least, I'm a member of the IAPA, our association, the EMEA Safety Subcommittee. I'm a member of that committee, where we meet bi-annually, and well, not right now, discuss any safety issues primarily that come from the parks, whatever that is, like near miss incidents, stuff like that. That's and then basically create collateral to teach our members, the parks, of best practice. How can we avoid certain incidents? So that's what that committee does. Briefly on Advantis, the company, established in 2017, so 3.5 years ago, in the heart of Switzerland. By the way, this is a traditional Swiss outfit I'm wearing today in honor of that. Just so you know, that's what the farmers in the mountains wear when they bring the cows out. So thought it was appropriate. We are by now a team of 7 motivated individuals across the world, primarily in Switzerland and Vietnam. What we're in business for? Best in class amusement ride and device risk assessment software. So that's what we're trying to accomplish. This is our vision. By now we have more than 25 companies using it either in production or in a trial phase. So more and more we're spreading the brand, and we're spreading our customer base, which obviously then at some point helps everybody. If the more we believe, the more that use the tool, then the more companies speak the same language, and so that so far for the company. Now let's get started on the standards. And as I said, let's start with the big picture. I just want to make sure I have everybody on board. Big picture, why, how this all works together. What are the players in our industry? So this is a slide that we've used multiple times with IAPA, and also this is content that we have created under IAPA for governments. So this is at a very high level where we talk to governments, also referred to as authority having jurisdiction. Sorry, I need to move my mouse here. That's a bit cumbersome. Okay, got it. Over here. So let's start with the actual ride. So we've got the actual amusement ride and device, and we have these players, these entities around. We have the authority, so that's any governmental, wherever the ride is installed, that's the government around it. Then we have a designer manufacturer that designs the ride, builds the ride. We potentially have a separate installer. We have an owner operator, and then there's an inspector auditor. So those are the players. So first thing first, the designer manufacturer is supposed to design and manufacture according to these standards. And I'm listing these 3 standards: ASTM, EN, and ISO. Don't memorize the numbers, not that relevant. It's just these 3 standardization bodies. So those are, he knows, following these standards, he knows supposedly what to do on the design and manufacturing side. The installer, same thing. There are some particular requirements for him, but when it comes to the owner operator, the park knows what it takes. Again, what are the requirements in the standard of how to safely own or operate a ride. Now, by this layer only, everybody assumes that this is actually being done. So the general public sitting in a coaster assumes that the designer manufacturer did the right thing. They assume that the owner operator is operating the ride according to these standards. And also the jurisdiction, the authority having jurisdiction, these guys here assume that everything is correct. This is without having an authority, an inspector auditor looking over what these guys are doing. And that's the next layer down. So now we have an inspector, an independent company outside of these others and of these guys here, and he has his own requirements. There are in the standards requirements of what he needs to do to inspect. Is he designing correctly? Is he manufacturing correctly? Installing, yada, yada, yada. You got it. So that's him. Well, okay, that's one thing. He's going to report back his results, but then there's one piece missing. How do I know that he is qualified enough? And so that's the accreditation process that would then come from the authority, which when he's accredited, then the authority is going to give a permit to operate the ride. That's very high level how all this works together, all the different stakeholders. Okay, a bit more detailed. EN 13814 is that standard on the EN side. developed by Sen TC, originally created in 2004 and heavily revised in 2019. So as of last year, it came out. And what's special about this, it actually gets adopted by all the EU member countries. That's just how the law, so to say, works with these standards. But there's also others. There's a total of so we've got 20 member states, and then it was actually used and adopted in 42 countries. So there's many others that decided to go with the EN standard. What is new in the 2019 version in relation to what we're talking here is these two terms, DRA and OERA. DRA stands for Design Risk Assessment, and OERA stands for Operation and Use Risk Assessment. So although in the 2004 version, the designer manufacturer, the guy in the blue box there, was already required to do a risk assessment all these years, but never the owner operator. So this is new. The OERA part is new, which is actually part of the reason why we decided to start Advantis, to give some help for these folks that are totally new to this. Give them a tool that they can work with. So as of 2019, the requirements are out for all the new rides. So every new ride going into operation needs to have an OERA. So that's for Europe, mandatory, every new ride. On the ISO side, developed by TC originally in 2015, and this being revised right now by the Russians, who are the secretary. So the revision, real quick, it's adopted by only a handful of countries. So there's not a big user base on around this standard so far. But what's new in the 2020 version, it's 100% harmonized with EN 13814, which is great. This is what we're all looking for. We're trying to harmonize these standards so that a manufacturer doesn't have to design, has to have two designs in order to meet different standards around the globe. So we will accomplish 100% harmonization. So back to the risk assessment, the DRA, OERA also applies to the ISO world. Wherever ISO is adopted, that is a requirement. The third one is ASTM, which has multiple standards where the upper two have like 3 parts each. ASTM has more like 20 different standards, and they're constantly being updated. You see above how long it took to revise the standard, 15 years. And in ASTM, this turnaround is much shorter. Sometimes there's 2 versions coming out per year, but normally at least 1 new updated version of every one of these standards per year. It's mandatory in the US to a certain extent, yeah, and adopted in many other countries, such as South America. There's many, around the globe, there's many countries that decided to adopt ASTM. And what we're looking for, hopefully, in 2021, to have this new standard on risk assessment that Kevin and I and many others are working on. We just completed the draft, and I'll show you a few things on that one. You have a first view on what that includes in a minute. Okay. So the other standards that I mentioned are the ISO and the ISO standard and ANSI. Why I'm bringing this up is because the ISO 12100 standard is the very generic risk assessment standard in machine safety. And that is being referenced by EN and ISO. So because EN and ISO do not have their own, like I'm talking the industry standard, do not have their own risk assessment requirements. They simply reference ISO 12100. That's why ISO 12100 has relevance. But it's a general machine safety standard. And at ASTM, we decided to go the other route, to actually put specific requirements in our own standard for our industry with all our needs versus just referencing a machine safety standard. But it does have the fundamental process of what a risk assessment is defined. On the ANSI side, NCB 11.0 is basically the US counterpart. So this one, as well as the ISO, is heavily used in our work, what we're creating here, the content for our risk assessment standard. It's also machine safety standard, but what it does better, we believe, is the whole supplier user concept. The ISO 12100 is strictly looking at a machine builder who needs to build a safe machine and has all the requirements for him. It doesn't look so much at the user of the machine, which for us is obviously important, given the DRA OERA thing. So that's why we look a lot at the NC B11, and we had meetings with both committees, the chairman of both of these committees, and they're happy actually that we share concepts and content of their standard, which is great. So there's no competition there. So let's look at the risk assessment process. So I'm sharing just some graphics, no content, and I hope Kevin's not going to kill me, from our new draft. So it's basically the main process of what a risk assessment includes. And this is new information for pretty much everybody on this call, at least how this is going to come across. I know if Guillermo is on, he's actually one of the contributors, so he's already seen the draft with the actual language. But I just want to show you the process, which, get my mouse here, has these fundamental blocks here. So you have some prerequisites to start with. You then, and I'll touch on what those are. Then you jump into hazard identification. You got to do your risk estimation and risk evaluation. If your risk is too high, you got to do your risk reduction. And at the end, when it's all good and done, you got to document this. So this is in very high level what the process is. So if you look at each of the phases, we break it down. The prerequisite, so this is basically the stuff you got to do before you start the show. We call this also like set the stage. Before you start playing your play, you got to do these things. So you got to build a team in the first place, because don't do this in your room with or without COVID. You have to do this in a team effort. Next one down, you got to know, you got to define your scope, the scope of your assessment, and that's one of the 5 topics that we're going to talk about. You got to know what is included in your risk assessment that you're about to do and what is not included. It's actually more important to know, or that everybody knows, what's not included. So that's what this is. And then the next one down, my mouse keeps jumping here. Collect the information for the assessment. That's basically know you're right. You got to know you're right first before you do your assessment. A lot of people jump on an assessment without having all these details defined, and then the assessment is not really connected to this particular attraction. When all this is done, then you shall define the tasks, and we'll talk about that again in one of the 5 items. So I'm not going to touch more on this. So that's what we would like you to do in the first box. Second box, hazard identification. Okay, so first you got to identify hazards. You're going to identify hazardous situations, And then you're going to identify hazardous events. Those are potentially new terms for you. And well, again, I'll talk about it in an example of what we mean by that. So that's hazard identification. Now it gets interesting. Okay, so now we're at risk estimation, evaluation, risk reduction. And because it's a little complex, we have to put it in one chart, because one without the other makes no sense. But this is basically the iterative process, as you see with those two arrows in the center, that how a risk assessment works. So basically, you do your initial estimation. I'll get my cursor here, over here. When you have estimated the risk, you evaluate the risk. If the risk is if it's acceptable, you're done. If it's unacceptable, you're going to go into this loop here, and you're going to apply your risk reduction measure, so another new term. And after applying this risk reduction measure, you look at your risk elements again, you estimate them, you evaluate. Are you good? No. Okay. I need to do more. I need to do something else. You do another loop. You look. You good? No. Okay. One more. And you can do this however many times until the team comes to a conclusion. Now we've adequately reduced the risk, and you go to your next step, which is you document it in a report. Again, very high level, and I'm not going to dive into details because, trust me, we can speak all week about this. Normally, what I'm talking about in these 90 minutes is a 3-day workshop, but includes actual examples and group work and such, and very interactive. So, okay, this is an interesting part I want to share with you. Because of what you just saw, because of this process, a risk assessment is not just some lyrics you put together. It's not comparable with a letter you write your grandma. A risk assessment has certain requirements as far as the form goes, not the content, but the form. And that's why I'm bringing up this chart. So we have to distinguish, when we look at the risk assessment, the form and the content. What's also given is we can talk about completeness and correctness. The EN standard for inspection, remember there on the initial chart, there is that one part, part number 3, that is giving the requirements for the inspector. And what he's tasked to do as far as his design review is he needs to check the documents for correctness and completeness. That's what it says in the standard. So when it comes to looking at a risk assessment, basically, he's going to look for that. He's going to look, is the form complete? Is the form correct? Is the content complete? And is the content correct? So I came up with this chart. You see in the center is 0, no good. In the corners, 100%. And then when we look at 2 examples, it could look like that. You have the orange risk assessment, not so good. And you have the yellow risk assessment, the assessment of the assessment, basically where an inspector would give feedback to the author and say, yeah, yellow is not too bad. You're 60% complete on the form. There are some parts missing, but you're like 80% correct of what I see in the form. And when it comes to content, yeah, you're 80% complete. I still see some pieces missing. And here again, maybe 60% correct on the content. So maybe not so good. I mean, the other one is really not good. But what I personally started when I do a lot of third-party review work for a large park operator from Central Florida. And I started doing these things in my reports on the executive summary. So an executive sees right away, where am I with this document? Oh, okay, got it. Yes, looking good, big or small. So the reason why I'm bringing this up is, and you got to forgive me, but every once in a while you'll get a commercial break on this presentation. That would be the first one. Advantis takes care of the form. So all the blue stuff, everything in blue, Advantis takes care of it for you. You don't need to worry about the form. We make sure the form complies with the standard. You can focus on the content. So that's one reason for having Advantis. Okay, done. The 10-second advertisement is over. Let's get back to the meat. Well, kind of. Here we have a classic, or show you the ride development process. And I say ride, but it can be any development. So anything you develop should have an analysis phase where you make up your mind first, then have a design phase, then have a validation phase. So analysis is like your theory of operation, that you define first what the ride, how the ride should operate, being operated, what the ride is in the first place, very high level, conceptual. The assessment falls into the analysis part. At least it starts there, big time. That's where the majority of the work is for your risk assessment. And then the resulting specification. The specification of how to design. So the design, this is where you do all your detail engineering work, your calculation, where you come up with your drawings, mechanical, electrical. This is the actual design. Validation is design reviews and all the acceptance tests, such as FAT, factor acceptance test, site acceptance test. Well, this looks very balanced, but let me tell you, what I've seen in these years is the analysis portion is hardly there, and the size of the circle represents the hours spent on each of these phases. So usually very little is done up front. They jump right into the design. Let's get them drawings out there. Let's do some coding. I don't know what to code, but let's just code. And then, you know what? Let's just ship it to the site, bolt it together, and test the heck out of it. Once we just validate until we feel satisfied, and I'm sure it's going to be safe. So that's how historically a lot of ride development took place. But this is no longer an option, and some companies experienced that firsthand from jurisdictions that said, through a third party, said, look, I no longer just want to see the end result. I want to see how you got to the result. So show me your risk assessment, show me all your thoughts that got into the design. I don't not just want to look at the schematics or the final design. So back to these three bubbles, and the colors are not picked coincidentally if you look at the top left of your slide there. And so is the name of the company. So what is important, where you want to get to, is your analysis drives your design. That's where you want to end up. If it's not doing that, if you start your design before you do your analysis, then your analysis is just a paper tiger unrelated to your design. And that's what's still happening a lot. A lot of people say, oh, gosh, got to do this risk assessment. Yeah, let's just do something. And what's the solution? Yeah, let's just make it work, like make it match. That's not what the risk assessment should be. It should drive your design. The requirements need to come from the risk assessment. What the analysis should also do, or if done right, if you have your specification at the end of your analysis phase, it feeds into your validation. so that the person writing the test plans knows what to put in the test plan, because it's all in the specification. If you have SRS, safety requirement specification, well written in the first place, writing a test plan for it is a no-brainer. If not, it might get a little complicated. And then the third and most important step then is validation checks your design against the analysis. So the analysis gives the specs, what needs to be done, and validation checks, does the design withstand the original specification. And there is some differences between verification and validation, what that means. I'm not going to go into that detail. Takes too much time. Speaking of which, where are we? We're good. Good. With that, I will open the floor for some questions. Let me see here. Oh, seriously? I need to do that. Okay, let's see. Just raise your hand in the chat if you want to say something, and I'll enable you. Not all at once, please. Don't be shy. There is no such thing as a stupid question. Kevin, if you're on there, did I miss something? Oh, well, let me see here. See if Kevin's here. Kevin's not here. Okay, so Linda is, thank you for that, here. What is the most missed content that, oh, content that you see? I'll get to that. That I will touch on exactly these kind of things, and then maybe we'll cover that question at the end. So as far as the standards, you're all blown away. It's all good, no question. Guillermo, is the ADV model followed by EN and ISO? I wish. No. I mean, not the industry standard. It is referred to by the ISO. It's actually the 13849. So on the control side, because as you probably know, in software development, this is the V model, the ADV, also referred as the V model in software development is quite common. And so it actually is referenced in the machine safety standards, but not in our industry specific standards, unfortunately. But that's okay. Like one small topic, the safety life cycle is also a very fundamental, basic process that any product, whatever it is, has. Now you can either work with this, you can look at the safety life cycle or the life cycle as a whole of a product, or you don't. And this life cycle concept has been around also for about 20 years, and now at Astm actually starting to implement it, to integrate it. Because I personally, I'm very much in favor of this concept, because it helps everybody to understand, okay, I have a life cycle. Okay, yes, I need to do, like with the V model, I need to first do my analysis, I then design, I then build it. So the life cycle has a few more steps. I then build it, and then install it, and then it's at the end of the installation is commissioning, validation, and then I go into operation, and then I potentially go into decommissioning. So the life cycle has a few more steps. Hannah, when do you anticipate the new ASTM risk assessment? That's a very good question. As I said on the timeline, we have completed the draft, and the draft is currently like the main body without the appendices. The draft is currently being reviewed by a larger group, and we want to incorporate their feedback by the end of the year, beginning of like January, to be ready to go out and ballot the first drafts in springtime. Now with ASTM, the balloting process is everybody that is a member can vote on this, and when they vote, they can vote negative. And if it's a negative, we have to address the negative and either change the content based on the negative, or say, look, non-persuasive, we're going to ignore the feedback. So this is going to take some time. And we had over 240 participants in our meeting 2 weeks ago with the biannual ASTM meeting. So this is like 50% of all the attendance in the entire week. So there's a lot of interest in our work, which is great, super cool. But yes, it creates some pressure, and we will probably get some negatives that we have to plow through. So that's why I conservatively wrote 2021. That's definitely our goal to get out by the end of next year. And at that point, that's with ASTM. As soon as it's out, it applies. It applies for new rides right away. But no, never mind. Eric, do you know of any connection and or corporation present or did? No. I mean, I look closely of what they're putting in and what's going on. We do have a liaison with one individual that I every so often reach out and ask what the developments are, but they created their own requirements as far as risk assessment, not really consulting any of us, so not a big surprise. But we do have a connection with them. Yeah. What kind of new revisions to ASTM are happening at the moment? Well, as I said, F24 has about 20 plus standards, different standards, and there's constantly work in progress going on in all these different standards. And normally each of these standards is being published once a year. So you see like F2291 is a number of the main design standard, and then -20. That means where's version 20. Sometimes there's a 20A and a 20B. So there could be one coming out in springtime and one in the fall. I personally am in favor of reducing that rate to be a bit more harmonized with EN and ISO, because if it's such a fast-moving target, it's sometimes hard to keep up, and it's particularly interesting when an incident happened. Then you have to track back, well, which standard applied when that designer designed it, like what applies. So I personally would favor more like a 2-year coordinated update cycle versus this constant moving target. So I can't give you a definite answer. There's so much going on. If you're not if you're not a member, become a member. It's $75 per year. If you're a student, it's I think as an affiliate, it's even less. And then you get access to these standards, and you can follow it, and you can, especially now since we're holding these meetings virtual, it's even less expensive to join the meetings and be involved. So there is roughly 1,000 members in F24, and about 250 to 300 usually attend the physical meetings, and now we had 450 in this last session being virtual. So, Jim. Yes. like we have a German manufacturer that is constantly required to document their projects and be reviewed by TÜV as a pretty rigid, as you probably know, third-party inspector. And they are, yes, they've blessed this and they're fully on board. Yeah. When it comes to TÜV, they actually made an offer. They wanted to buy Advantis. I said, sorry, not yet. So no, we're constantly exchanging information with TÜV. We have a good exchange. They ask me questions, I ask them questions. So it's a very good exchange. Okay, so thanks for these questions. I suggest we're going to move on and start looking. Yeah, we're 45 minutes in, looking at these key elements. So I'm going to do something here. Get ready. This one here. Turn this one off, and off we go. Okay, so I'm going to list them all real quick, those 5, and then we dive into one by one. So the first one is we're going to talk about scope definition and the importance of it. Second one, we're going to talk about task-based. What does it mean? Why does it matter? Initial assessment and follow-up assessment. If either one of the two is missing, it is not a risk assessment. Very important. Seen many, many times. We'll talk about it. Risk reduction measure, the separation between requirement and solution. Why there is some benefits to that. Oops. Oh, sorry. Never mind. And then again, on the risk reduction measure, so the measure I'm taking to reduce the risk on the control system, on how do I connect my safety function with the risk assessment? How does that work? That connection. These are not all of them, but these are some 5 things that I've seen that I either struggled with or that others struggle with and have some questions. That's by far not a full list. Again, I could go on and on and on, and we're going to do other sessions where we dive more into these details and cover others. And you know, if you have particular interest of what you believe should go as one of these in a next webinar, shoot me an email, and I'm happy to put it on the list and covering it with a larger community. Okay, so let's jump on the first one, scope definition. So as I said earlier, this is basically where you set the stage, and also called the prerequisite. What is really important that the risk assessment team understands what the scope is. Everybody. What is included, what is not included. Have your customer to understand what you're considering and what not. That's very important, especially now that we've learned about this DRA, OERA, where on any given attraction, the designer has to do his DRA, design risk assessment, and the owner, operator, has to do his OURA on the same attraction. So they better know from each other, well, what are you considering? I'm considering this. Is it matching? Because ultimately, the owner operator, the park, they have to cover everything. And he has to know what you as a designer manufacturing are already considering. And I'll show you some examples, what that is. What is in this respect that is very important is the communication early on in the development. It makes no sense that you come to the site for commissioning and then first time show them a risk assessment. This is, by the way, what I consider. Oh, okay, I didn't know you didn't consider the spectator, so I need to consider the spectator. Oh, okay, sorry. So this should be very early on, ideally go into the contract. That this is already nailed in the contract, that the two parties know, oh, okay, this is what I'm what I'm supplying, because in the contract it says exactly this is the scope of supply, this is the equipment, and with that it should say, well, you know, by the way, I'm doing the risk assessment, but only limited to my equipment. Kind of makes sense. But then there are some nuances of other things of what I could consider and what I maybe don't want to consider. So with that, let's look at what I mean by that. Let me open up the scope and let's switch screens. Okay, so we are now inside Advantis. We look at the, we have here our so-called base module scope, and under scope, we have certain things predefined, such as people, use cases, and operating modes. So when it comes to people, you should really make up your mind, who are you considering and who are you not? So here we just have an example of what the different people interacting with the machine could be named at. For example, spectator, you can have a description of what that means. Okay, it's a person outside the ride perimeter, and this person is classified as untrained and uninformed. Okay, clear to me. And then you make a statement what is in scope and what is out of scope from your perspective. If you're a designer manufacturer, I'm saying, look, I'm considering any risk related to my supplied equipment. But if I'm designing a tower ride and that tower ride has a closed perimeter, and there is the park decided to put the queue line right around the tower, and a shoe or a cell phone falls off and falls into the queue area, this is all not my fault. This is, first of all, I didn't build the queue line. I didn't decided to put no roof on the queue line, and I'm not operating the ride. All I can do is I can tell the owner operator, hey, no loose articles on the ride, but he's operating it. So this is clearly something that needs to go into the OERA, just as an example. So out of scope is any risk related to objects, equipment not within scope of supply. Passenger. With the passenger, as a designer manufacturer, is kind of hard to get out of it. I mean, if you're supplying a roller coaster and say, I'm not considering the passenger, you're pretty brave. So here we're saying, and by the way, the passenger is the person sitting inside the PCU. PCU stands for Passenger Carrier Unit, just a generic term, whatever it is. Again, it's classified as untrained, uninformed. Can't ask too much from him. Fully considered. The participant, that's an interesting one. That's the guy basically between the passenger and the spectator. So when I decide to go on a ride and I enter the queue line, I transition from being a spectator to being a participant. And then as I transition and go into the ride vehicle, I transition from participant to passenger. And then on the exit, same thing. Passenger becomes participant, participant becomes spectator. So it's a very, very structured, formal way. And if you describe this properly, then it's clear when we do the next part, which is the tasks. This is very important, that you have distinct terms and everybody knows, okay, this is what you mean. And then again here, participant, I consider risks with my supply equipment, but look, if you're supplying a catwalk in the station and he falls on the catwalk, it's not my problem. It's not my equipment. It's your risk. You got to cover it. Where it gets very interesting is staff, operator and technician. Okay, so here, so the operator is the person operating the ride in regular or irregular operation. And again, related to the supplied equipment. This is what I consider. Technician, same thing. So this is one way of wording it. You can also word it differently, where you say, well, look, regular maintenance, what he's doing every day, I consider, but if he has to change a motor, like irregular major maintenance, this is covered by work safety standard. These things I do not consider. This is all, it's important that it is defined somewhere. On the use cases, this is kind of new, and it's something, just the term itself, something that was inserted in F2291, that it's design standard at ASTM. So basically, this is how the ride is being used, and we break it down here very easy in essentially four different use cases: regular operation, irregular operation, regular maintenance, irregular maintenance. Regular operation, you're operating with guests, and here again, as a designer, you got to consider regular operation. It's tough. Irregular operation is evacuation, when you have to evac or recover people, whether it's out on the track or in the station. And here, for example, one definition is, as long as we, as the designer manufacturer, have authority over the machine, this is covered. So that means powered evacuation, where we bring the trains back, where we can lower it in slow speed, and all this is all covered, all the risks associated with that. If you do the other, when it's unpowered, when you tie down the ride vehicle and you get the guests out there, this should be your evacuation procedure in your SOP, standard operating procedure. So this is a park responsibility. Again, this is very important that you put this down, because the inspector, as we've learned earlier with this chart, he's going to look, is it complete and is it correct? So is it complete? Is the content complete in regards of the scope definition? That's what he's going to look at. If there is no scope, he can always say it's not complete. He didn't consider everything. So that's why we believe this part is very important. Operating modes, this, I'm not going to touch on this. This is where we connect the actual operating modes, like normal mode, maintenance mode of a ride, with the use case. And there's a matrix for that. So this gets a bit too far in this session. The one thing I want to touch on is these user-defined scopes. So here you have endless options of what you want to define your own. So human behavior is obviously a very important one in our industry. Again, key that you say, look, and choose your words wisely here is my recommendation. Any risks related to supplied equipment and associated with foreseeable human behavior are considered. So the key word is foreseeable human behavior. What is that? And you can reference EN has a definition for that, EN 13814. You can relate to that. What foreseeable human behavior is, because obviously that's a big one. I just today heard of an incident that happened with a large operator, a near miss, that you think, really, some kid did this. And they were able to react. The operator was able to react and stop the train before it came to an incident. But yeah, it's this is a biggie. Employee, yes, you got to consider accidental misuse. They're simply too stupid to operate, versus unintentional. That's the big one here. What is intentional? What is unintentional? So sabotage, all this, I recommend not consider. Intentional disturbance, so this would be the whole, like outside people trying to disturb, not even the person want to ride, but outside disturbances. So again, these are just examples. Life cycle phase, which phase are you considering? In the standard, we are clear. We say at a minimum you have to consider the operation and use phase of the ride. If you then decide, well, I'm also going to include commissioning, validation, the erection, installation, all that, that's fine. If it's a fixed installation, we do not recommend doing that because that is huge. When it's a portable ride, you have to consider it because you're taking this portable ride up and down every so often. So you even have to consider transportation at that point. But for a fixed installation, we recommend stay with operation use. Okay, then environment is another one. Say, look, certain things that are prominent in this area, like high winds, seismic threats, that needs to be considered. But then there's others that are simply like avalanches or asteroids and stuff like that. We're not going to consider. Okay, I open the floor for questions. Again, if somebody wants to say something, just raise your hand or say so in the chat and I'll enable you. Happy to do that. Kind of boring if I'm the only one talking. What do you... Okay, so Mudir's asking, in some cases, the project team or consultant has direct contact with the manufacturer, not the owner operator. How the OURA will work here? Well, if the consultant is only working with the manufacturer, which in many cases by the standard is required that he's looking basically over the designer manufacturer, he should have the authority to ask for the OURA, because ultimately, that's a good question, because the way EN and ISO have worded the requirements around DRA, OURA, I'm not particularly fond of, because they kind of sit next to each other. So it's basically up to like an inspector auditor to see, well, are all the risks covered? Because the designer manufacturer is doing his risk assessment based on his scope definition, what we just saw, and then the owner operator is kind of in another bubble doing his thing, and somebody needs to see the connection between the two. And at ASTM, we're trying to avoid that by a different concept that. And like when you look at reality out there, what's happening is the owner operator, the park, is installing an attraction, the full kaboom, and putting that into operation. So they are, no matter what, if there's an incident, they're gonna get them first, and then they're going to look at, well, okay, this is actually related to a part that was supplied by this particular manufacturer. So let's look at his risk assessment. Was it covered in his risk assessment? So that's why at ASTM, we now came up with a concept of new roles. So there is a producer role and there is a user role. So basically, in many cases, the designer manufacturer is the producer, the owner operator, the park is the user, but then there's a third role called integrator, because somebody is integrating all these different pieces into one, and there's always more than one. Even if it's a single ride, the ride will have a fence around it, and somebody built the fence. So we have a supplier of a fence. Theoretically, he should supply the risk assessment, which probably your fence builder down the street is not going to give you. So as an owner operator, you have to do this part yourself in the capacity of an integrator. So, but back to the inspector needs to have access to these documents because he's the one that can actually make a statement. Again, going back to correctness and completeness, is it complete? Are all the risks that he can come up with based on his experience, are they covered? Hope that answered it. Ken? Okay, how do you recommend approaching the OURA as a ride manufacturer when a standard product is developed which can be provided to multiple amusement parks? You don't have to. As it is a ride manufacturer, you're tasked to do a DRA that covers the product, all the risks associated with the product. Of course, you got to think of risks that come along with the operation. And that's where it gets interesting when we look at the risk assessment. So you do your risk assessment, you do your DRA, but as you do that, you will come across hazardous events that you've identified that when you then do your risk reduction measure, you come to realize, well, this is not even in my scope of supply. So at that point, you want to make a clear statement that you've identified the hazard, you have done your initial risk estimation evaluation, but you're not responsible for mitigating that risk. So we call that at ASTM, we call these transferred risks. These are risks that are going to go in some document. They need to be transferred to the owner operator. So a lot of it has to do with the operation. A lot of this goes into the manual. So your task is you have to, when you do your risk reduction measure and say, well, okay, look, the operator needs to do this and this and that. All you can do is you put that in the manual, because the manual is an integral part of the ride. The ride is only safe if it's been operated according to the operations and maintenance manual. So, so transferred risk is also a new term that we're coming about, and that will I'm sure spark some interest when people understand what that means. Hope that answered your question. If not, just let me know. Hannah. Okay. So do you recommend defining the producer, user, and integrator within the base scope? No, that's not your job. That's exactly something that we're trying to do the groundwork for you on the standardization side. That's where a lot of people want too much from the standard that we cannot provide. They want a high degree of detail that we give them basically a cookbook of how to do a risk assessment. That's not what the standard will do. The standard will set some basic requirements, and what the standard will do is set the ground for common vocabulary. That's important, that we talk the same terms, same terminology, and the same, and the producer, integrator, user module is one of that. That is important that we all understand, okay, on this particular ride, I'm actually the producer and the integrator, because the park asked for a turnkey. I do everything. I hire the fence guy and I put the fence around it. I'm doing the integration, everything, and then I hand it over to him. Turnkey, so-called turnkey attractions. Happens, but not too many. So I wouldn't say you don't need to include that. Leave that to us. One last thing to do. Guillermo. Yes, he's asking, does Advantis have built-in templates or libraries that could be used for building the scope as a starting point, perhaps predetermined common terms as used in the example? Yes, originally what we did, we had reference projects that we would give when you come on board. You would get these reference projects. We now have a new concept called project templates. So within Advantis, we have these project templates that you as a company can create different templates. Let's say you build water rides, but you also build coasters. So you have a project template for roller coaster, and you can create a project template for water rides and another one for towers, which has all these elements, scope, all a lot. is you can predefine in these templates. And we provide a default template with Advantis, and then you can take it from there. So yeah, the answer is yes. Good. You know what? Let's move on. We got 4 more to do. So let's see here. Next one, task-based. Oops. Okay, so the risk assessment is a top-down process. That's just, I didn't invent that. That comes from the standard. There's bottom-up, top-down. An FMEA is a bottom-up. Risk assessment is a top-down. And with this top-down, I'm going to show you a list now that goes top-down, but to confuse you completely, I start at the bottom. I start with the end, and then I build up. So bear with me. So at the very end of the hazard identification process is a hazardous event. So this is what we don't want to happen. This is our starting point to do the initial risk assessment, the estimation and the risk evaluation. So the hazardous event is built on a hazardous situation. And I'm taking an example here that is not related to our industry, but in Europe we have a lot of train stations, especially in Switzerland. We do love trains, and so this is a common scenario. You've got this train coming, and there is no protection, no nothing, and yeah, you get the picture. So this is a hazardous situation per se, socially accepted. Yeah, well aware. This might go through with 60 miles an hour. I've got the family there with the stroller. No big deal. So we have a lot of hazardous situations in our industry, in our rides. So what creates a hazardous situation? Well, it's a combination of at least one person and the hazard zone. That creates a hazardous situation. This picture here, obviously, we have the hazard zone with the train coming by, and we have at least one person close by there. So an ARD, amusement rider device, has many hazard zones, as I don't need to explain. So the initial question, and that's why I started bottom up, how are the persons interacting? And that's why it is so important to have your scope definition. You have a clear understanding of what are the individuals I'm going to look at. And once you've defined it, guys, sorry, just realized that. Sorry about that. Here we go. Okay, never mind. What you all heard, now you see it. Okay, sorry about that. So you see the picture I'm referring to, and you see the list. So again, how is the person interacting with the ride? So if I go to, and I'll switch back to Advantis in a second. I'll just prepare it. That is key. And that is before you start your risk assessment, you have to define the tasks. How is everybody that you just defined in your scope interacting with the ride? And let me switch you back now that you've seen this list, right? Okay, see this? Okay, so with Advantis, we let you define different areas of your ride. Basically, you can model your ride however complex you wish to build this. So this is an actual model of an actual coaster with all the different mechanisms. And then based on these areas and the people that you have already predefined, you then have these tasks. So here is, you're creating a task which is simply saying this and this type of person is doing this and this and that. Nothing went wrong so far. It's just describing how all the people are interacting. So one example here that I'm going to touch on is a participant is walking through the retail shop. Simple task. Participant is walking on a platform inside the load-unload session. Technician working on track switch during preventive maintenance. So when we look at one of these, it includes the person, the area, the use case, and linked the operating mode. So that task definition is very important, and I see that neglected. Back to Linda's question, what is missing? It's that many risk assessment are not task-based. So what is the opposite? If it's not task-based, what is it then? Well, basically, they're looking at the ride, at the physical build of the ride, and say, what if this breaks? What if this snaps? What if this has? And that is simply a what if, and that is, at that point, you end up in an FMEA. It's a failure mode and effect analysis. What if? What if this does? What if this contactor doesn't turn off? And that at that point, you're doing a bottom up instead of a top down. By going task based, you're automatically coming top down. And the task based approach shows you risks in a greater extent than just simple through an FMEA. I'm not saying an FMEA is inappropriate. I totally recommend doing FMEAs on mechanical structures and mechanical assemblies, not on controls. On controls, we have other forms that I'm not going to go into too much detail about, but no need to do an FMEA these days on controls. Okay, so task. When we look at an actual, so let's look at that guy that was walking through, the participant is walking through the retail shop. So now something goes wrong. In this case, believe it or not, this is an actual case that I had to document. Human misbehavior, unforeseeable human behavior. So this is the hazard now. One human sitting on shoulders of other human. At that point, they had an unexpected reach envelope, and the hazardous event is or was, hypothetically, participant sitting on shoulders of other participant reaching for rotating show fan. That's what I had to analyze. Keep in mind, the participant sitting on the shoulders had to be 12 years old in order to fall into the 95 percentile of reach envelope to actually make it up to the fan. But that particular customer wanted me to do an analysis on this. So here is now how this would look like. You do an initial risk estimation evaluation, which actually gets me to the next point, which is great. I'm going to show you right away. So with this information here from the hazardous event, I can do my initial risk estimation evaluation. In this case, I've got these two parameters, severity and probability. I have 4 different parameters on severity. I have 5 levels on probability that I can pick from. And then, very important, can justify, make some comments. In this case, pretty extensive comment of why we picked this level. I'm not going to go into too much detail, but basically behind this is a risk matrix. This is the default risk matrix that Advantis provides, but by no means you would have to choose exactly that. This is a 4x5x3, 4 levels of severity, 5 levels of probability, and 3 different colors, so 3 different risk levels. Again, this is an actual example that I had to put in a report. So let me switch to the presentation. I'll do a better job this time. Trust me. Okay. So you just saw the initial assessment, right? Actually. So immediately after hazard identification, we're doing the initial assessment. What is important without any safety measure in place. So nothing, and why is that important? Because you need to, especially on the severity, you need to know how bad is it. in order to have a rigid risk reduction measure against it. If you're already considering some measure, you don't get the full impact of how bad can it be. So no safety measure in place, no risk reduction measure, how bad is it? And then also the probability of occurrence. What is the probability of occurrence? Equally important as the initial one is a follow-up. And trust me, I've seen many risk assessments that have either the first or the second. So there was never an initial one. They just listed some things, what we do, and then had a final assessment done, and everything was green. Yay, good. Or the other one, really bad at the beginning, and I do some things, but never followed up. And that is where an inspector would tell you incomplete. It's not a risk assessment. I've had that with literally in a live session. So you can do follow-up assessment after every risk reduction measure, or at least at the end. So, all right, switch you back. I'm gonna get better at this. Switch you back to the example here that we have with our rotating fan. So we have this initial guy here. So the first risk reduction measure is of design, and basically what we decided to do, that the surface of all rotating parts of this fan shall be smooth and rounded. Okay, that's fine. And there is a document that reference, okay, in there, and here's the follow-up, says, okay, now I'm reducing it from initially severe to minor because it doesn't have sharp edges. The probability of occurrence hasn't changed. It's just the blades are smooth, but I can still reach it to the same probability of occurrence. So the event actually happening has not changed. Which gets me to the next point. I'll watch my time here. Gets me to the next point. You see the separation of requirement and solution. So this is now where this is a fill gearing thing. This is not required by the standard. Standard doesn't require you to do this, but I do, because it has great benefits. By having a requirement phrase in the first place without really knowing what the solution is, you can put all this on paper way before you have your design done. Go back to the ADV model. When you do your analysis, you can think of all this in the first place without having an actual solution. The solution comes later. And here, the solution can be either worded out what it is, or it can be just as here, a reference into an existing drawing or document. The separation between the two has great merits. Switch you back. What I mean. This is item 4. So separate risk reduction requirement from solution. As I said, allows the requirement to be worded early in the development. Very important. It's considered a closed loop assessment. So basically, like in Advantis, we throw an exclamation mark if you don't have a solution there. So you need to go back to your initial risk or your risk assessment that you've done at the beginning of your development. You need to go back and make sure you have a solution for all these risks. There are certain risk assessments that just put it on a like a punch list. Okay, it's a punch list item that somebody needs to follow up. But with this closed loop, you need to go back and actually show me a solution. When it comes to operational, you can say at the beginning, the right manual shall state this and this and that, but you don't have a manual yet. At the end, you can just put the reference in. Okay, it's in manual chapter so and so. And what's really key is the intellectual property issue. Back to what Mudir had asked about the inspector. A lot of ride manufacturers, for obvious reasons, do not want to give out a risk assessment because it includes intellectual property. Well, if you have a separation between requirement and solution, you can give out a risk assessment only showing the requirements so that the reader knows, oh, okay, this was considered. I don't need to see the solution as a park. I know this was considered. Who needs to see the solution is the inspector. The inspector needs to see because he needs to do a justification. Is it correct? Is it complete? He needs to see, oh, okay, first of all, yes, he did consider everything. And then, oh, yes, and the solution, I believe the solution matches the requirement and therefore the risk is properly mitigated. So an inspector auditor will have to have access to the entire document. And with Advantis, you can create a report with the solution or you can create a report without the solution for that purpose. So you send the inspector one, a complete one, but your customer, your park, you only send them out the one with the requirement. Okay, last but not least, we're good. 5 minutes to go. How to connect a safety-related control function to the risk assessment. I see a lot of people struggle with that. It's like, okay, I know I have this PLE safety function, but how the heck do I connect this to a risk that I've identified upstream? So let's look. No, let's finish this here. What is important, you only make a call for a safety-related control function in your risk reduction measure requirement. All you say is, hey, we need a safety-related control function to deal with this thing here. Don't be specific of how you're going to do it. You don't know yet because you're early on. You're in the analysis phase. Design hasn't happened. All you know is, I can't do this with any other technology. I need the control system, then Spark is to come in and take care of this. So I need a safety-related control function. Then there is another standard that I haven't touched on that tells you what you need to do with this safety-related control function. So you need to do an assessment with that standard. There's two. There's an ISO and there's an IEC standard you take for that. And that basically then gives you the performance level, a PL, or a seal level if it's with IEC. So that's your second step. Then you're going to have a safety function implemented as per that other standard. And that one you present back to the risk assessment, say, here's my solution. Okay, so how does that look like in real terms? Here we go. All right. Okay. So this first risk reduction measure was of design. Fortunately, let me close it all up. Okay, so we have the hazard identification, we have the initial risk estimation. The first risk reduction measure was design. Fortunately, on this example, the second one is controls, so we can look at that. Okay, so what I just said, at the requirement stage, all I say is I need a safety-related control function to limit the torque of the show fan to a maximum of 20 Newton meters. That's all I'm saying. Because we picked controls here, Advantis automatically inserts that other standard, what needs to be done, and has a risk graph that you now need to fill out. And this has slightly different parameters. I'm not going to go into too much details about this. You pick your parameter, and based on this graph, it spits out the performance level. In this case, PLC. Okay, that's pretty easy, so to say, that that you can do a torque limiter with a PLC rating on it. So also automatically generated are the safety requirement specification. So Advantis requires you to have an SRS worded out, and this is automatically here, all linked. The performance level is linked, the operating mode is linked. All you need to word out here is what exactly does that mean? So now we're specific, because this is the requirements that will go to the design engineer at the red bubble And he gets this specification, and with this specification and his skills, he knows what to do. When I tell him, look, I need a VFD, a drive, frequency drive with a torque limiter, and it has to have a PLC rating, try and find one. And by the way, the limit is 20 Newton meters. And that 20 Newton meters I put in purposely because that is important. So on this requirement level here, you have to be very generic in one sense, but very specific in other sense. And that's another one really, really tough for people that don't do risk assessments every day. What needs to go into this requirement? Why I say this matters, because this is a parameter that goes into here, and this number, sure enough, will go into the acceptance test plan and will be validated at some point. However, through analysis, through testing, but this value will be validated. This is very important to have specific numbers there. We have another example here about a collision between two coaster vehicles, and then I'm going to stop. PCU collision. In this example, the hazardous event already says passenger injury due to rear end collision between PCU A, stationary at block 2, and moving PCU B at 2 meters per second. I need to have that information. If I don't have the 2 meter per second information, I cannot do the initial risk estimation. Because if that number is 30 meters per second, I would not pick severe, I would pick catastrophic. That's why be specific in the right manner is ultimately important. And that's where, again, a little advertising here, ching ching, a consultant can help. If you have a consultant that has some experience with exactly that, what matters to go into this paper, we're here to help. No, this is really where a lot of people struggle. At some point, they put what Pepperl and Fuchs sensor they're going to put into a solution here. That doesn't matter at this stage. It matters these performance parameters. They matter, not prescriptive solutions, but performance parameters matter. So in this case, this one was a simple interlock between, this is basically block system. The block ahead is occupied, so I cannot start. And then because of severe, what we had upstairs, we get a PLE in this case. By this example here is a PLE, and the safety requirement then are as well. So in normal mode, the block 1 friction wheel drivetrain shall remain in STO. That's a safe torque off, is what that means. So it has to remain off condition if the block ahead, block 2, is in occupied state. So with this, a skilled, trained controls engineer knows how to design this. He better. And then here's the follow-up, and we are in the green. And with that, I switch back to the presentation. Oh, hold on. Last button. Oops. We're done. Just in time. But of course, I'm happy to answer any kind of question you have. Sorry, I rushed a little bit at the end. So again, you can raise your hand if you just want to verbally ask, and I'll okay, if ride manufacturer and client both use the Advantis software, is there a tool within the program to transfer the residual risk easy to the client? Thank you for that, Kuhn. Yes, there is. Yeah, there is an integrated transfer when they're both using it, because I can then, as the designer manufacturer, I can either create a report of these residual risks, a PDF that I can send them, or within the tool, I have the ability to say, okay, and this user is going to get them. And basically there's an icon in the inbox and you see, oh, okay, then it lists him all the hazardous events that the manufacturer has identified and transferred to him. That's a big one for us, that we provide this integrated solution. And that's the benefit of having a web-based, database run software. We believe this is very powerful going forward. It allows for future technology that we can do, also provide some guidance of how, just statistical evaluation of solutions, including AI in the mid to far future. And I think we can benefit as a whole industry from this kind of consensus, like data, big data, but in a good way that helps everybody. That's what we believe the future is gonna be like, and so hopefully more will come on board in the very near future to give us more data. Any other question? Again, you can just also simply just type me an email and let me know. First of all, what you thought about this. Was it okay covered? And then if you have some specific questions on the content that I went through today, and also topics for future webinars. I will do some more on the tool itself, because we have some students that are also joining us right now that are doing a competition. Iowa State University has a competition going over the next 6 months, where they do basically have to design a little ride, and the risk assessment is part of it. And so we will give them free access to the software so that they can play with the software and get familiar with doing a risk assessment. So I'm going to be doing some tool training for these guys, and we will announce it through the normal newsletter channel if anybody else wants to join. So more than happy. Well, I guess with that said, I want to be aware of time. We all have other commitments. We're 7 minutes over. Sorry for that. I had a lot of fun. Hope you too, and see you another time. So long.